All right, hello Algebra 2 people. Today we're going to look at section 7.6, exponential equations with same bases. Now, if you notice, it is a break from logarithms. We're not going to do any logarithms, but what we're going to learn today that you can do with exponential equations, you're going to be able to use to solve certain logarithmic equations. So it's going to be very useful in our next lesson. So to start us out, let me give you an example of what we're thinking about here. Let's just take for example, if you got 2 to the third, and somebody says, let's set this equal to 2 to the x power. And they said, solve for x. Tell me what x is going to be. Well, if you think about it, if 2 to the third is going to be equal to 2 to this x power, the only way that these sides could be equivalent or the same would be if x was what? X would have to be 3, wouldn't it? So what we're getting at is that if you've got an exponential equation where you've got the same base on both sides, you can simply set the exponents equal to each other and solve that. The base, in fact, doesn't even matter as long as they're the same. Now, therein will lie part of the issue is, the bases do have to be the same, so you might have to do a little bit of work ahead of time, I guess, in order to get the exponents equal. But as long as those bases are the same, you can set the exponents equal. All right, so let me write that out. Excuse me. If two exponential equations are equal to each other, and have the same base, the exponents must also be equal. If two exponential equations are equal to each other and have the same base, the exponents must also be equal. Actually, I think it should say if two exponential expressions are equal to each other and have the same base, the exponents must also be equal. I think that makes a little more sense. All right, so let's put this into action. We're asked to solve for x. And we start out, bases are the same. So we can basically ignore those 3's and set x is equal to 2x minus 3. And from there, we can solve it. Now, what's going to be a little bit tricky about these is you never know what kind of equation you're going to end up with. We're going to see a lot of variability here, so be patient, be patient. This is a linear equation. I'm going to get the x's together. I'll subtract the 2x over, get negative x is equal to negative 3, divide by negative, and get x is equal to 3. Now, the nice thing about this is you can check your answers. You can take that 3, plug it into your original equation, and double check that it is indeed a solution. Example 2, we start to see things right away that you're not always going to have the same base. And when that happens, the way you need to approach the problem is you need to think, well, just maybe I could rewrite this using the same base. And often, I'll look at the smaller base and see if I can like square it, if I can get it to equal the other base. But I'm not seeing anything doing there where I can just square this and get these to be the same. But there probably is a way to do it. But I'm going to go for a common base that is smaller than 4. I'm gonna rewrite 4 as 2 squared. And on the other side, I feel pretty confident that I can write 8 as 2 to the 3rd power, okay? Now that the bases are the same, I'll multiply what was already up there. But now that the bases are the same, I can ignore those bases and I'll distribute, and I'll get 4x plus 2 is equal to 3x plus 15. And I can solve this linear equation, subtract the 3x over, I get x, subtract the 2 over, I'll get 13, just like that. But it all started with, I rewrote 4 and 8 using the same base. 4 is 2 squared, 8 is 2 to the 3rd. When you can rewrite them using the same base, you can solve for those exponents. All right, let's look at example 3. Now, there's a couple options here. I could try to, I usually try to see if I can rewrite the, if I can rewrite the bigger number using the smaller base, and there is a way to get there. But it might be easier to look at these and think, well, what base would be common to both of those or be easily used to write both of those? And I'm thinking a base 5 would be good. For example, 5 to what power would get you 1/5? Well, 1/5 is 5's reciprocal. And a -1 exponent will make 5 its reciprocal. Okay, 5 to what power will get me 25? Well, that'll be 5 squared. Now notice what you write here should be equivalent to what's above. Okay, what you have right here is equivalent to what's above. Notice that on our previous ones. 2 squared is 4. 2 to the 3rd is 8. We're rewriting these numbers using the same base on both sides. Now from there, we do have to recall that we need to multiply by what's already up there, what exponent was already there. Bases are the same. Distribute. We got a linear equation again. Let's get that. Let's see, I'll get -3 is equal to -x, divide by a negative, and I get x is equal to 3. And again, you're welcome to check your answer using a calculator if you'd like, or without a calculator, however you want to do it. Okay, let's keep moving on here. Now this is kind of interesting on example 4 because we actually have 2 variables. We've got a's and we've got x's. But we go back to the instructions and it says solve for x, okay? So I really don't have to stress much about what a is at all. I'm curious what x is. But something that's a little bit odd about this is I've got a 3a and I've got a 9a squared. Well, you know what? It would be impossible. Well, I wouldn't say impossible, but it'd be very strange to rewrite 3a using a smaller base because, it's just difficult to do, even to wrap your head around it, and to some extent. So I'm going to leave this 3a alone. And on the other side, though, okay, now I can see. Since I left that 3a alone, I'm going to write down 3a, and I'm going to think, what exponent can I raise 3a to get 9a squared? And it turns out 9a squared is just 3a squared. Now let's write in our exponents that were already in there. And now that we've got our bases the same, we can set our exponents equal. And I'm going to go ahead and distribute. Again, we've got a linear equation. I'm going to go ahead and I guess I'll subtract that over. I'll get negative x equals 4. X is equal to negative 4. All right, for our next example, we've got 5 and 125. 5 I can't really rewrite very easily, so I'm going to leave that alone. And 125, I'm going to write using base 5. 5 to what power? The third power. And now let's write what's left over. Bases are the same. So we'll set square root x plus 8 equal to 3 square root x, like so. And now what we've got, interestingly enough, is we've got a square root equation here. And, you know, people tend to kind of freak out with this, but no need to freak out. Think of it this way. Think of it as you've got a square root x and a 3 square root of x, and think of those as like terms, and they're like terms that you want to get together. So I'm going to subtract a square root x to the other side. From there, I'm going to get 8 equals, and think of this as I've got 3 square root x's, and I subtract 1 square root x. Well, how many are left over? 2 square root x. You cool with that? From there, to get x by itself, I'm going to first divide by 2 to get 4. And now, class, what can you do? What's the inverse operation of a square root? Well, to undo that square root, we would square both sides, and I get x is equal to 16. How do you feel about that? All right, so now next up, you're gonna have to do something here that hopefully it'll make sense, and you'll practice it a little bit because it's gonna be back. It's gonna come along in a quiz and some later notes. Okay, what's tricky about number 6 is determining what base you should use. You've got a 27 and you've got this 3 square root 3. Well, I know that 27 can be rewritten as 3 to some power, so I'm assuming that my base I'm going to use for both of these is just going to be a base 3, but things are kind of complicated over here with that 3 square root 3. So I'm actually going to zero in on that first. Let's rewrite this, okay? I want bases and exponents. I don't want radicals. So I'm going to rewrite this as 3 times 3 to the 1/2 power. So a square root and a 1/2 power, those are equivalent operations. So, so far so good. But here's the thing, I don't have a single base 3, I've got 2 bases. Let's combine those. Do you remember what you do to combine these if the bases are the same and they're multiplying? That's right, you add them, you add the exponents. So from there I'm gonna get 3 to the, and yeah, the easy way out would be to say 1/2 power, 1 plus 1/2 is 1/2. I don't like that so much. I'm not a big fan of mixed numbers. I'm going to rewrite it as, you could think of this one as a 2/2, and then when you add it up, you'll get 3/2 power. So it's 3 to the 3/2 power. I got it down to a single base 3. So now I go to the other side, and I rewrite 27 as 3. Do you know what that's going to be? 27 is actually 3 to the 3rd power, and it multiplies with that x minus 2. So you can go ahead and distribute it and get 3x minus 6. And we've got our bases the same. So we just set 3x minus 6 equal to 3/2. And then from there you can grab a calculator or you can do it by hand. I'm going to do it by hand. So this'll seem overcomplicated for those of you that just punch it into your calculator. But what I'm going to do is I'm going to add a 6 over, but I'm doing it by hand, so I'm going to get a common denominator since I'm adding. So I'm going to make it 12 over 2 to get a common denominator. 12 over 2 is 6, okay? Common denominator, so I got 3x is equal to 15 over 2. And then from there, I've got to divide by 3, but because I got a fraction over there, I'm going to multiply by the reciprocal. So I'm going to multiply by 1/3, which gets x by itself. And then I can simplify before I multiply. So we've got a common factor of 3 there. So I simplify it, and then I got 5 over 2. Now, if you use your calculator, please don't give me a fraction answer. Please give me a fraction answer. Or please don't give me a decimal answer. Give me a fraction answer. So you could have 5 over 2 or 2.5. That'd be fine. But let's avoid 2.5 because then it looks like we rounded. And we didn't. We got an exact answer there. Okay, so class, practice. Practice is so important on these. Notice I did a lot of the more complicated ones, right out of the gate in the examples, quite a few without the same bases and quite a bit of variety. There's a little bit of practice on the easier ones, a little bit of practice on the harder ones, but make sure you practice and keep in mind the key is on Canvas. Thanks so much for watching.